Out. All right, now the event is being recorded. And good afternoon, good evening, depending on where you are. Welcome to this virtual recruitment event for our RU program in Smart Structural Technology. And I am Zhao Suojiang, a principal investigator of this RU program at San Francisco State University. Together with me, we have Professor Juan Casedo, who is the principal investigator at the University of South Carolina. And it's also our pleasure to have three of our past participants, Sam, Jill, and Justin, join us to share their experience on the program. And here is what we are going to cover in today's talk. First, Professor Juan Casedo and I will briefly introduce the program to give you some background information on what we are joining, right? Then we'll pass the stage to Sam, Joe, and Justin to talk about their experience on the program. So from a student perspective, what are you going to expect? We also set aside some time for the Q&A after that. So I would like to ask you stay muted before the Q&A section so that we can have a smooth transitions on this. If you have any specific question regarding to your applications, we'll be staying after 5 p.m. the PDT here to help you out on those, okay? With that said, what is our program look like, right? And here is an overview of the program. It is a collaborative program between San Francisco State and the University of South Carolina, which means that the RU participant in this program will be hosted in either San Francisco State or at the University of South Carolina. To bridge the research gap between academia and industry, one unique aspect of this RU program is the partnership with the industry. This partnership is very special. It offers you the opportunity to not only doing research with the professor at the university like the traditional RU would do, but it also give you the opportunity to work with the industry professional on those research projects side by side in the office of the company. And as the participant, you'll be trained to serve as a catalyst to drive this knowledge exchange between the academia and industry. With that said, now I'm going to pass the stage to Professor Casedo to talk about what this 10-week program looks like.
Thank you, Sachu. My name is Juan Caicedo. I'm at the University of South Carolina, and this is really a quick overview of the program, so you know generally what to expect. One of the things that I want to mention is in this upcoming year, we're still going to see what happened with COVID, and we will adjust things appropriately, but the dates that we have in mind is June 7th to August 13th. If for some reason you have not finished your quarter or your semester, or you need to start before that, just let us know. We are somewhat flexible depending on the situation on those starting and those ending times. So don't take this as a 100% requirement. There is some flexibility there, but this will give you an idea what to expect. So, you know, we know that you are not fully trained on smart structured technologies. So what we try to do in the first 2 weeks is to give you a little bit of training through some workshops. And the way that those workshops work is we ask you a question, we give you some background in the form of a lecture or some readings, and then we ask you to answer that particular question. And is a very nice way of learning, because what you're gonna do is you're gonna start collaborating between the two different sites. So perhaps you might have an expert in San Francisco that knows something, or somebody in South Carolina that knows something. So you might exchange some ideas that way. So that, again, that form of training is in the form of workshops and in the form of some tasks that you're going to complete. But the goal of that task fully is for training purposes, for you to learn more about smart structured technologies. Let me see if I can go to the next slide. Can you go to the next slide, please? Oh, there you go. And then from weeks 3 to 9, what is going to happen is there's going to be a collaboration now between academia and industry. And that's going to happen by you doing research both at the institution, but also doing it with the industrial partner as well. So you're gonna learn not only about the fundamental research aspects, but the reasons of why we're doing this research. What are the implementations of this research and potential applications that the research might have in the future. The other advantage of doing this is that the research that we're doing is not comes from a need from industry. So hopefully these will have applications in not too long in the future, right? So that was going to happen between weeks 3 to 9. You're gonna in some cases we're gonna have a going to industry 1 day or 2 days or 3 days. In some situations we have had where the industry partners might offer more or less days for you to be there. So that's also something that might be a little bit dependent on the project and depending on the industrial partner. But the idea is to increase the number of days that you're going into industry to give you more independence on that. And then lastly, on week number 10, we have the program wrap up. And basically what this is finalizing a report, finalizing a presentation for the industrial partner, giving this presentation and basically trying to tie in any loose ends that you might have in your research. Understandably, this doesn't necessarily mean that this is the end of your of the road in terms of the research that you might do. So you might continue doing some of the research and afterwards as well. So that's something that is an option there as well. All right. Embedded into the 10 weeks, we're going to have some city tours and some technical tours. So we might go and visit, for example, here in South Carolina, we have the State House is base isolated, so we can go and visit the State House. In San Francisco, there are several high-rise buildings that are being constructed, and some of the industrial partners will have some tours for that. And also there are some cultural activities, because what you are going to find out is that the connections that you make right now are going to be connections that are going to last the rest of your life. So you might not realize that the person you're working with now, maybe you're going to find them in 10 years from now working for another company or working at another institution or university, and you say, oh yeah, I remember that we did this 10 years ago. That actually does happen. So that is extremely important to do those connections. And then at the very end, we had the final presentation of your research that is given to the industrial partners and the other REU students as well. Around the different, every other week, so often we have these workshops and roundtable discussions. And the idea of that is to give you an opportunity to stop and reflect on what you're doing, ask questions, and kind of ground what you're doing into the fundamental research again. So this roundtable discussions allow you to kind of reflect on what you're doing and get a little bit of perspective on what on the research that you're doing. And then every now and then there are some workshops that are offered by the institutions or we offer independently, and they can help you perhaps with information about how to apply for other opportunities, or how to communicate better, or how to do social media, and how do, for example, how you prepare your LinkedIn profile and things like that. So there's some embedded workshops through the 10 weeks.
Thank you, Dr. Caicedo. And next, we are going to have first Sam Benzoni to share his research experience through the program. Sam was an undergraduate student at San Francisco State when he participated in the RE program, and now he's a grad student at Stanford University. Sam, the stage is yours.
Hi, thanks for the kind introduction, Dr. Zhang. So my name is Sam Benzoni. I'm currently going to be entering my second quarter at Stanford a week from today. And I graduated from San Francisco State University in May. And before that, I had been an undergraduate research assistant under Dr. Zhang for 2 years. And this REU program was very shaping for me in a number of ways. And I learned a lot about research, how to conduct research, and also about carbon sequestration and the greenhouse gases associated with the building industry. So my research project in this program was that my partner and I built models trying to sort of quantify the carbon emissions associated with each structural element of a high-rise building and try to understand how much of a certain material, such as wood, which in its upbringing sequesters carbon, might be needed in order to create a building that has carbon neutrality towards the end of its construction. And so this project looked like a number of things. We had learning experiences from the jump in understanding what sort of things go into the design of high-rise buildings and things like that. There was a lot of things that I'd never come into contact with before when I went into the industrial partners' offices, and our mentors were very helpful and guided us very well so that we could pursue this project as best we could. So we investigated the use of a wood slab system in certain high-rise buildings to try and off-put some of the carbon emissions associated with the construction of other parts of the building that cannot be made with materials that are carbon negative or carbon neutral.
Hey, Sam, just a quick questions. So previously, you have been working with me on different research topic, but later on, you're actually working with the industry partner on this green gases projects, right? What are the differences you feel between research in academia and industry, and would that be helpful for you to consolidate the research path that you would like to move forward with? And if so, in what way?
Definitely.
Oops.
Through my experience in academia, I was introduced to academic research, which is very interesting and serves a very similar purpose to the industrial research, though the end goal is slightly different and the steps in the process along the way are slightly different as well. So research in academia, as I've learned it to be now, is an attempt to provide a more concrete knowledge on something than that may not have been known before, such as the behavior of a certain thing or the chemical processes involved in manufacturing structural elements. And those things are very important to quantify, but at the end of the day, these sort of things are are not the easiest to translate into industry and to sell to an owner of a high-rise building. And so that's where the difference comes in. In industry, you're actually looking to have a final end product, which might be marketed in a way that has benefit for the company to be able to do their engineering work. And that was something that we came into firsthand in our project, was that we developed a little tool that quantified emissions and had graphic displays of what sort of carbon neutrality we would be achieving by using certain floor plans associated with volumes of wood and how those wood elements would cancel out other structural elements' emissions. And so instead of in academia looking into a more in-depth reason as to why those elements might have had the certain greenhouse gases and emissions associated with them, and how we could look into that a little bit more, we kind of just took those things at face value and experimented with how all these things could come in together for a final product of a building and how that might affect the landscape of the future, given that with California having historic fires and water not being very present, we need to combat climate change now more than ever. And so this is true for every industry, and in the building industry, a quantification of greenhouse gas emissions associated with your building might be an incentive for an owner to want to build their buildings with the future in mind.
Thank you very much for sharing your experience on this.
Of course.
Next, we're going to pass it to Jill. Jill participated in this program in 2018. She was at the University of Michigan for her undergrad and now in Colorado State University working toward her master's. Jill, feel free to take it over.
Okay, thank you.
Do you want me to stop sharing and then so that you can share?
I think I've got it. Can everyone see my screen?
Yes, I can.
Okay, great. Hi, everyone, and Happy New Year. My name is Jill Peretta, and I'll just be talking a little bit about some of my experiences during the program in 2018. So first, a little bit about me. As Dr. Zhang said, I went to the University of Michigan for my undergraduate degree, and it was here that I learned about the REU program. So my junior year, I ended up applying and luckily got in because it was a great program, and I'm super happy I did it. But I was in the San Francisco State University group, and I worked with Skidmore, Owings, and Merrill on a project. And then after I graduated from Michigan, I went to Colorado State University, where I'll be graduating with my master's in structural engineering in May. And I think that through this program, I know that I got this bridge internship this past summer because during the interview, they just kept asking me about this REU program and were very impressed with the whole thing. So for a typical day in the program, we all lived on San Francisco State's campus in an on-campus like apartment style dorm type of thing. And I lived with the 3 other participants in my program. It was really nice because the commute to the lab was quick. And if we were going downtown to SOM, it was just a quick BART ride away also. So as was mentioned before, we did some training for the first 2 weeks. We learned how the shake table worked as well as did some experiments with it. We took some tutorials on software we'd be using for the rest of the summer. And we learned some useful career skills such as elevator pitches, updating our LinkedIn, and plenty of other things as well. And then after the training for the first 2 weeks, we started working on our research projects. My project was working to see how connecting 2 high-rise structures with a sky bridge would affect the structural behavior of the 2 individual structures. So part-time, we would be in the San Francisco State Lab, working with my teammate as well as Dr. Zhang on the project and getting suggestions from that, but also kind of seeing what we wanted to do with the project. And then after that, we went into SOM's San Francisco office and got some perspective from people in the industry as well, which was very helpful. I think the most exciting part of the program for me was presenting our project at the end. It was really cool to be able to show all that we worked on all summer and put the work into SOM's structural team. And then I think the best part was at the end of the presentation and during, we were asked questions and given feedback about how to strengthen our study in the future and how our findings could eventually aid in Skybridge design for them. So there's a lot of benefits to the program, I think. One of these is that you can gain experience in both academia and industry. So I know I was kind of between whether I wanted to stay in school and go to grad school in the PhD track or go right into the industry after I graduated. And this program kind of gave me a little taste of both. So I ended up going to graduate school and then will eventually go into the industry after that. But it was nice to be able to kind of see both sides and how the two work together as well. We also all got to perform like very interesting and relevant research projects. The one that I talked about earlier that I worked on, as well as the two other participants at San Francisco State, worked on a very cool project, and at University of South Carolina as well. It was also great to live in San Francisco for a summer. It's somewhere that I never thought I would be. And I got to spend 10 weeks there with some really nice people and get to explore the city, and just an overall great city to spend the summer in for sure. And then I got to work with professors and students from different universities. I've worked like on research projects with people from University of Michigan in the past, but it was nice to get perspectives from people all over the country and see like how they do things differently, and kind of, I think it just made the projects a lot stronger. And it's also a great resume builder. Like I mentioned earlier, I've been asked about it in pretty much every interview I've done. And it's great that you can say you have research and industry experience as well. You also are able to make some great connections with people at universities as well as at the companies we worked at. I've kept in contact with a few people from SOM, and they're really great people to have on your side for sure. And for the conference, I actually was in another country at the time, so I was unable to attend the conference, but I was texting the people that went today from my program and asking them about it, and they said it was a really great experience. They got to go to California Institute of Technology and presented their projects, and it was great, they said, to listen to everyone else's presentations and learn a lot from that, as well as kind of show off what they worked so hard on the summer before. Yeah. Thanks for listening. I have my email here if anyone has any other questions for me later.
Thank you very much, Jill. And for the audience, the presentation will be shared later on as well. So if you would like to contact Jill for some advice, that information will be available to you later on as well. Let me share my screen. All right, next we'll have Justin, who also joined us in 2018. Justin, I remember that when you first joined the program, you seemed uncertain about if you like to work toward your research path or not. But later on, after the program, you joined a national lab as a research intern, and then now you continue your graduate study at Texas A&M. So I'm just wondering if you could share a little bit about what shaped your career directions and what aspect that this program contribute to decisions.
Yeah, sure. So thank you for the introduction also, Dr. John. So my name is Justin Kim. I'm currently a graduate student at Texas A&M University. My undergraduate degree was also at the Texas A&M University in civil engineering. Now I'm working to get my structural engineering degree. And I'm currently a employee at the Los Alamos National Laboratory, working part-time jobs, doing some simulations on the on the structural health monitoring part. So from my experience, after I want to give my personal experience. So after finishing the REU program, two thoughts had in my mind. First one is that I have to learn more stuff in order to advance my career, especially in the structural engineering that I wanted to get into. So for the first 2 weeks, as Dr. Caicedo mentioned, there will be some form of a training period where you're going to be learning some new concepts in structural engineering and also in some smart technologies. And from my experience when I joined right after my sophomore year, where I didn't have that much of a domain knowledge in in structural engineering, especially I only took mechanics and material as the farthest on my on the dynamics part. So there was something that I didn't fully get at that certain time, but as the research program went through, I started to slowly get it, and then eventually gave the presentation on some of the research that we did at the University of South Carolina. But there was still quite a lot of the aspect and also some application that I wasn't fully understanding. So my decision was to actually attend graduate school where I can learn some advanced topics like plate theory, advanced mechanics of material, finite element analysis, and all this kind of stuff to actually get a better understanding of what the structural engineering is and more of a true aspect. Um, and for and my second thought was basically I wanted to continue the research, not just on the research that I conducted in the University of South Carolina, but also some of the other research topics that I wanted to pursue. So and also there was a kind of a dilemma on whether I should be going to industry right after undergraduate, or just continue my graduate degree. So there was one option where I can actually get an industry internship that focuses on R&D and like R&D and structural engineering. And one thing I can tell you is that there's not that many companies that does R&D in structural engineering or civil engineering. It's the research is usually done by the academia or other institution. So it was pretty difficult to actually find some internships that actually does offer some R&D. But so I found about like maybe 3 of them, and then so I applied, and then luckily I got interviewed from both of the 3s, and one of them was the Los Alamos National Laboratories. And one thing I wanted to want to mention is that during the interview, all the employers were asking about the REU experience that I had, especially focusing on the research that I did. The research I did, simply put, is the gate analysis using the principle of structural dynamics, like like understanding the human steps through the vibration on the floor, how the footsteps are impacting on the building, and maybe and understanding how they walk, and also hopefully diagnosing any chronic diseases. And that is something that some of the employers and also some of the research associates at the lab that they have never heard of and also never thought of. So it was very interesting topic that they wanted to talk about. And then they really thought the REU has an amazing experience, especially as an undergraduate. There's not that many chance where you can go to other institutions to conduct research. It's usually for graduate student that does that, and then also conducting a good research where you end up doing presentation to some of the industry and academic leaders, and also doing some posters. So I believe that the REU experience I had in 2018 was one of the deciding factors for employers to eventually hire me. And then, yeah, I eventually ended up in the Los Alamos National Laboratory as a undergraduate intern last summer. And then I'm continuing to work at the National Lab as a part-time remotely because of all the coronavirus. And then my future plan is to eventually graduate in my master's and then go to the National Lab as an R&D engineer, maybe working for a couple of years. And then I haven't fully decided on the PhD degrees, but if I do want to pursue PhD, the National Lab also offers the PhD degree in structural engineering through the UC San Diego. So that is one of my options to do. If this is a first-time experience, like conducting research, I can say that REU is definitely one of the best experience that you can have, because it gives you, well, one thing I can say is that it gives you a wider perspective, because if you're conducting research in your home institution most of the time, there is a certain aspect, certain topics that university will focus more on. For instance, Texas A&M focuses a lot on transportation. So even in structural engineering, a lot of the research that we do is focusing on the railway, bridges, and then also just pavements and all those kind of stuff. But I didn't want to do horizontal structure. I wanted to do vertical structure. So that was one thing. And then definitely going to South Carolina, doing some other structural engineering research, especially on the vertical part, and also in depth on structural dynamics. Definitely gave me a wider perspective of how to do structural engineering, and also give a better judgment eventually when it comes to a problem. I can give a different ideas, and then sometimes it works out pretty great. So.
Thank you very much, Justin, on the insights on how this program actually shaped your career directions. And we have been talking quite a bit. Now, I would like to open the floor for the audience. If you have any questions, you can either type in the chat so that I can monitor and read it out loud, or you can unmute yourself and go ahead and ask your questions for either Justin, Sam, Joe, Professor Casedo, or myself.
Hi. This is out to any of the students, but I as a freshman personally, I have little to no experience with the industry and how everything works. And I was just wondering if there's any prior knowledge that I should be familiar with like going into like this industry, or just like going into this program if I get in.
All right, let me answer that question. So thank you for the question. That's a common question that we have, and the answer to that is not really. We do want to see that you have started your engineering path, basically. Also, if you're a computer scientist, there are some projects that require computer scientists. So in reality, what the program provides is a crash course on the topics that you really need to know to be able to do your research. The type of topics that we will teach you about are more beginning of grad school, but don't get scared about that, because the whole goal of this is to make it available for you to learn and to teach you over those 10 weeks, and to be able to help you grow on those aspects through those 10 weeks, so you can do some progress on that research. So in a nutshell, our expectations is that you're not going to know anything of the fundamentals of the research. And those 2 weeks, we're going to give you most of the fundamentals, with the expectation that's just going to produce more questions and more questions and more questions. We're going to help you grow on those areas. Dr. Yang, I don't know if you have anything else to add.
Right, I don't. Thank you for the answer, Dr. Casedo. And I'm just curious, Joe and Justin, you two, I don't think you have the prior research experience as well. So what suggestions or what aspect you would like to give to the potential candidates on this? Do you think that the 2 weeks training or workshop we provided is enough? Or do you think that there's anything else that we need to prepare for it?
So from my perspective, before joining the REU, I had a little bit of experience on the research, but not something that I can say that it's a oh, I conducted research. It's not on the level of that. But once joining the REU, especially just staying along with some of the peers from all over the nations, it's really a collaborative environment where we'll be learning a lot of the stuff at the same time, where you and also they're not going to know much about some of the topics that the REU will give on the crash course side. So it's like, by staying together and also being collaborative, you guys will kind of learn each other and also kind of question each other to get a better understanding of the topic. And eventually, as a 10-week program, it eventually grows, and then you start to kind of snap and then like understand oh, I think I get it now. And then I think that's one of the point of the REU is to expose undergraduate students who did not have the prior experience in research to fully get into maybe some of the research path that you want to be in, also get a better understanding on how to conduct research once you kind of go back to your home institution and want to pursue like maybe undergraduate research assistant or like, you know, some lab technician and those kind of stuff. So I don't think 2 weeks is not enough. I mean, I think 2 weeks is enough for a crash course. And then like once that's figured out, and then people can kind of start learning each other, and then like, you know, just talk to each other.
I have a question, sir. If I can.
Sure.
I'm international. I'm a sophomore international student at NSF REU, civil engineering student. So can I apply for this?
Dr. Casado, you want to take that?
Sure. Yes. So unfortunately, because of the type of funding that we have that is from the National Science Foundation, the program is only for US citizens or legal residents. So if you're an international student in a J or an F visa, J is visitor, so an F visa, unfortunately is not possible for us to support you under the grant.
And there's another question along that line is asking, are we looking mostly for civil engineering students, or any other engineering disciplines could be considered?
Yeah, so any type of engineer, and to be honest, I think we like to see people from other disciplines to be involved with it, with smart structures. The biggest discoveries and research are done not within the discipline, but among the disciplines, right? In the edge of disciplines. So if we had, for example, I don't know, maybe I'm gonna speak out of place here, but if we had a very interesting, let's say, biology major that is really passionate about this and has some fundamentals on engineering, that will be someone that we might be interested. So don't be shy of applying if you are if you're not a civil engineer, or if you're not a mechanical engineer or a computer scientist. There are parts of this research that really having a different perspective, having someone from a different field will be very beneficial as well.
There is another question regarding how many hours per week that we are expected to devote into the program. So I think that's probably a question that our past participant could better answer that question for us.
This program sort of will act like a job for the summer, or for the 10 weeks that you're there. And you will be reporting around, you know, late 8 a.m., hopefully before 9 a.m., and then having a lunch break and then leaving around 5 p.m. And it'll be similar for the days that you, I guess, remote into the office, or for your industrial days as well. And another thing I would like to add to what major students might be considered is that smart structure technologies actually have been multidisciplinary in their whole sort of use. And like the first finite element method was performed in trying to model airplane wings. And that's the same thing for the first structural health monitoring, was to monitor the structural elements of like aircrafts and stuff like that. And then Dr. Zhang and Dr. Casado both have done research that employ a health perspective on things, and not a structural health, but a human health, and how the human health might interact with the structure to provide signs of the human's deteriorating health through the behavior of the structure when interacted with the human. So I would say everyone is accepted in this sort of field and these research projects.
And thank you, Sams. And one of the principle, at least Dr. Casado and I was holding, is we believe work hard and play hard, right? We don't expect you to devote the whole Monday to Sunday and working on this project. You need to have some time to re-energize yourself and etc. So that's why in the beginning, Dr. Caseta showed you the setup for this 10-week. We are putting the different culture activity, for example, different workshop, different training along this whole program, so that you don't putting yourself in this mindset for the research the whole time, but you also have the opportunity to interact with the other participants, to look around the city that you are actually being host and etc.
Also adding to that, yeah, REU is also a cultural experience where you go to different states to actually conduct research, but not just research. You're actually learning some other aspect about how, like how people do and how people how cities are in different states. Just growing up in Texas, like I never been to South Carolina before, and then going to Charleston during the weekend has been one of my one of the best experience I had. Like Texas doesn't have like a pretty place like Charleston, so it was also a really good experience where you can have some fun with your peers and also eventually work hard with your peers, work hard with your peers during the day. So overall, amazing experience at REU.
Thank you.
I have a few questions.
Go ahead, Darnis.
Awesome. Does the application require a letter of recommendation?
Yes, so it's going to require 3 letters of recommendation. The way that we do it, 3 or do we ask for 2 or 3? I forget.
I believe it's 2.
2, okay, 2. But the way that we do it is a little bit different. We don't want to burden the people that you're asking letters of recommendation. So we basically ask for an email, giving us a few sentences about you. So you submit email addresses of the people who are gonna write your emails of recommendation, for lack of a better term, and we just send them a quick email saying, can you just tell us a few words about it? So it's not as involved as a letter of recommendation.
And also to add on top of that, we didn't require the letter of recommendation at the beginning, so that we require that once you are being selected or as show potential to become part of the program, that's the time that we send out those email requesting for the recommendation letters or the thoughts on you. So if you put down your professors on those reference letters and they haven't been contacted yet, don't worry about it. That's the process that we're going through.
Right. Thank you. Yeah, thank you for reminding me of that. Yes, so we don't ask for everyone. We basically ask for the letters on the top tier of candidates. Yes.
I see. Okay, and during the program, is there any CAD work involved?
Not necessarily. I guess it depends on the project, right? That's where, depending on the project, you might do a little bit of CAD. But I'm trying to think. I don't think any of the projects that we had in the past had any major CAD work. It has been mostly to do simulations, to do some experiments. In many cases, is to kind of come up with an idea that might work to solve a problem. So it's more in that on that type of mindset rather than doing CAD work. You might do some CAD work, perhaps for your presentation to show a final design or something like that, but it's not necessarily one of the focuses that we have.
And my final question is, what do you guys look for in potential candidates, like when you're going over applications and things like that?
So in the application process, there are some very standard fields, right? So there's like GPA, things like that, which are very standard. But we also have a part where we want you to tell us more about what are your expectations about the problem, what do you expect to learn. So we're not necessarily looking for prior experience on research, but we're more looking about what do you want to learn on the program? How do you want to grow in the program? So that's I think that's we're looking more on that aspect rather than any prior knowledge or prior experience on research on structural engineering or smart structures.
There's several other questions on the chat, Dr. Casedo. So the first one is, what are the other research topic as example, and are those topics developed by the undergraduate themselves or randomly distributed by the staff, or where are those topics coming from in general?
That's a really good question. So there have been all different type of projects. We had a project that worked with Geosyntech, that's a geotechnical engineering company that worked on evaluating some dams for earthquake engineering aspects. So they learn a little bit about probability and things like that, and that relates to smart structure technologies. There was another group that looked at using technology to have virtual tags for industrial facilities, and the particular application was to be able to tag either structural elements or to tag elements, pipes to look at release of gases. So applications of that in the area of smart structure technologies is, let's say you have an earthquake, you go into a structure, you tag virtually some elements that might be damaged so somebody else can come back and look at them, for example. We had a group that looked at what is the optimal design of structural systems, and Professor Yang probably can talk more about that one. So we have different type of projects over the years. And those are in addition to the ones that that have been mentioned so far. Those topics are usually established before the beginning of the program, and those are conversations that we have with the industry partners first. The main reason is we want to make sure that the topic is set. We want to make sure that it has some type of application for industry, because that's kind of one of the things that we want to embed into our research. Is not research for to answer a fundamental question, but it is research that answers a fundamental question that also helps with solving a problem for industry. So those conversations are happening beforehand. However, if you have a good idea, we're all ears. We might be able to actually use that idea to come up with an industrial partner. So yeah, that's everything is game.
Thank you, Dr. Casedo. Another question that we have from the chat is, what are the percentage of applicants get selected for the program?
Let's see, I don't remember the exact numbers. I think might be about what, 8%, 8 to 10%. Is that about right?
Yes. To give you an idea, right? We typically receive over hundreds of applicants. Last year is 120, and we are selecting 8 participants from the program. So we can do the math and see, so that's about like 8%, 7%, right? And another question.
I want to add something to that. I don't want that to sound discouraging. It's just try your best in the application. I think the write-up of the application, we read every single one of them. We score every single one of them, and then we meet and we talk about every single one of those write-ups. So don't get discouraged by those numbers. If you're interested in the program, apply and you know, just
right. And I echo that. And there are different aspects that we're looking at. So don't feel, hey, no, I don't have prior research experience, I'm not going to apply. We are looking at a lot of different aspects. So you most likely will stand out in some way that will be noticed. Another question that we have is, now given this current situations, first I would like to emphasize, now the summer program is still being planned as a face-to-face. But if later on something got changed, as we all experienced firsthand how unpredictable the 2020 could be, I'm really hoping the 2021 is more certain than that. But if we are going to move to virtual, what are the, what way that we could facilitate this collaboration with others? And how to make sure the teamwork is working effectively?
Yeah, that's a really good question, and I think there are some ways that we can do some collaboration online, and I think it's going to be more difficult if we're going that direction, but I think it is plausible. And to give you a reason why I think it might be possible is because we're seeing many industries moving to telework. So we might perhaps have an event where everyone participates virtually, and we have some type of events that are recurring within the program, and then we might be able to follow up with each individual participant that way. So we haven't quite structured it to be virtual so far. We want to do it in person, but I think we can make a meaningful program where the participant gets to have meaningful interaction among participants, also minimal interaction with faculty members, and also with industrial mentors, if that's the case. Yeah, I don't know if that answers your question or not.
If you still have more questions on that, please follow up on the chat or speak up. We can discuss more about it. The next questions on that is how to determine which school that you are going to be assigned to.
That's a very good question. So in the application form, you're going to have a preference. And what we're going to try to do is, as much as possible, we're trying to organize people by that preference. However, we might see that some projects might fit better to one person than the other one. So we might say, okay, we have this person who is a computer scientist, and this project might need a little bit of programming. Why don't we try to see if this person is willing to go to this site rather than the preferred site. So we try to accommodate that preference, but in some cases it's not possible just because of the type of projects that we have.
The next question is that we mentioned that we have subsidized housing on the flyer. So what does that include?
That's a good question. Yes. So yeah. So basically, participants of the program are living on the dorms of the universities. In both places, it's pretty close to the labs and pretty close to restaurants and things like that. The program does cover that. The program also covers your flights to the program and from the program. And something that we haven't mentioned so far in the presentation is a year after the program, there's a conference. So that was also included in the participant support. So transportation is covered, housing is covered, and then you have your stipend that you're being paid to be a participant in the program.
Yep, the stipend is $5,000 for 10 weeks. And I'm just curious, we haven't get a chance to live in a dorm. So what do you feel about it, Joe, Sam, and Justin? Is it good or is it terrible?
Mine was an apartment style. Oh, I'm sorry.
Oh, no. Okay.
But
no,
yeah. Oh, you go ahead. I'm sorry.
you can go.
But yeah, I'm just saying, like, my dorm was basically an apartment style where it has all the amenities included, kitchen. They have a nice fridge. So it was an overall pleasant experience than my dorm I had back in Texas A&M, and also the building to the structure lab is about like maybe 2 minutes away from the dorm, And if you go up maybe about like 5 minutes up, there's a state capitol in South Carolina, and they have like quite a lot of the restaurants that you can access to. So yeah, I don't think maybe the housing or food, those won't be a problem. And it's all gonna be covered, especially well, flight is gonna be covered, and then within the $5,000 stipend that you get, it's gonna be more than enough for you to have some, a good amount of food or just have some fun in the free time. So
Yeah, I like, we had lived in an apartment style dorm as well, like all four of us together. And it was great, especially considering how expensive housing is in San Francisco. It's really great to have it included in the program. And it's not like where we stayed wasn't in like right next to the city, but like I said, it's just a quick 10-minute BART ride away. And there's a lake right nearby if you like to walk or run. And it was a nice experience.
Thank you. That's make me feel better, right? So next question that we have here is where can we access the link for the Zoom recordings? So we are after this meetings, after the recording is available, our plan is to post on our REU website, which is listed on this slide here. And you can also scan this QR code that will also bring you to the REU site as well. In there, we are going to post sections that putting the link or the recording of this video there. And also with the presentation as well, in case you would like to have some information on that.
I have a question.
Go ahead, Kevin.
So is it a part of our requirements to stay together with the other group members in the same apartment, or it's just a recommendation?
Yeah, so if you're local, we might have this as an option. What I mean by that is we had participants that are actually living here in Columbia, South Carolina, or in San Francisco. So in that case, it doesn't make a lot of sense to have that dorm. But if you're coming from another place, we do want you to stay in the dorm, just because you want to be with other people that are in the same program. That sharing of the experience is part of what we want you to be part of.
Actually, Sam was one of them that's staying at their own apartment, right, Sam?
Yeah, so I was a student at San Francisco State University, and I had already signed a lease that covered the time, and it wasn't very far at all, and it was quite nice to, I don't know, it was probably a 5-minute commute from where I stayed, or 10-minute or something like that. And San Francisco State University is quite conveniently located with a lot of different buses and trains that connect every different part of the city. So if you are local to San Francisco or even Oakland, you could get to San Francisco State University very quickly. And it was pretty simple.
Yeah, I live in Oakland, so yeah, thank you.
Oh, you're in San Francisco. Okay, Calvin. All right.
I
Time
have a
is
question for Sam, if there is time left.
sure. Go for it. You have 1 minute.
Okay. So Sam, what was the thickness of the wooden slab that you wanted to replace over concrete? In addition, did you consider the carbon emission that went into the engineering wood, I'm assuming?
Yeah, so we did. So we did a lot of literature review looking into the manufacturing processes for things like dowel laminated timber and cross laminated timber. And we made some assumptions in our study, and at the end of the day, it was a hypothetical two-way slab with very stiff beam elements that would sort of outline the wood panel with a certain amount of concrete left on top of the wood in order to meet the code fire requirements for charring and such. And I don't quite remember how much what the thickness of wood required was, we changed a couple different variables, like the area of the wood as well as the thickness of the wood. And I want to say it got to be pretty thick, as the post-tensioning and pre-stressing of concrete technologies are quite impressive and can reduce your slab size to 6-7 inches. So it required a couple more inches than that to account for the charring concrete required to meet the fire code, and then to account for the slab elements. We didn't quite reach a completely neutral building, but yeah, the literature review was very extensive, and we looked into the carbon emissions associated with almost all of the structural elements associated with building, from post-tensioning tendons to the dowel laminated timber, cross laminated timber used in the hypothetical.
Thank you very much for everyone joining this event. And now it's 5:01. I would like to be mindful about everyone's time. So as I mentioned at the beginning, if you have any further question, or you have any question regarding your application, feel free to state, and me and Professor Cascada will be staying to helping you out on those. Again, thanks for everyone for coming, and have a great night.
Thank you, everyone.
Thank you. One thing might I add beforehand is that this program is a great immersion, and also the research that you will perform is quite relevant. During my time at SOM, I sat in on a research presentation from a professor and a PhD student at Stanford University before I even thought of applying there. And that presentation was on topology optimization, which was not my project, but the other group in the REU's project. And I wrote about that in my statement of purpose. And then in my advanced structural analysis class I took in the first quarter, the person who presented the research came in and did a couple lectures on optimization. And in a course that I'm taking this upcoming quarter, it's a structural engineering seminar where academics and professionals from all across the nation come in and speak. One of Dr. Zhang's co-workers from the time that he spent at Skidmore